Example 2. A pipe 450 mm in diameter branches into two pipes of diameter 300 mm and 200 mm respectively. If the average velocity in 450 mm diameter pipe is 3 meters per second, find Roman figure 1. Find quantity of flow in 450 mm diameter. Find the quantity of flow in 450 mm diameter. Roman figure 2. The velocity in 200 mm diameter pipe. In 200 mm diameter pipe. If the average velocity in 300 mm diameter pipe is 2.5 meters per second. Solution. Given data, how many sections do we have? We have section 1, section 2, right? And section 3. Now let's list the data in section 1 and the data in section 2. Identify section 1. What are you giving? We are giving diameter, meaning D1 is given to be what? 450 mm, which is what? 0.45 in meter. Next up, what are you giving?
The branches of the other two pipes.
That's all. In section 1, you're only giving diameter.
Okay. And velocity.
Velocity, meaning V1 is equals to 3 meters per second, right? Now, section 2. Check section 2. What do you have?
We have the diameter of the pipe.
This is the initial section of diameter 450. Then this pipe, this section 1, it's split into 2.
Yeah.
This section 1 split into 2. Now the first one is what? 300. While the other one is what? 200. So this is how it works. Your own section 2 might be 300 diameter or 200. This is what I'm saying. For your section 1, you might have it being 300 mm or 200 mm. Similarly, these two might be your 300 mm or 200 mm. You still get the same thing. Irrespective of the diameter, your section 2 and 3, you still get the same thing. Now, for section 2, let's say our diameter is 300 mm diameter, which is what? 0.3 meter. Then for section 3, let's say our diameter is what? 200 mm, which implies what? 0.2 mm, which implies 0.2 meter. Now, this is D2, this is what? D3. Check. What do you have again?
We have
the average velocity of what's it called? Section 2.
Okay, the average velocity of section 2 is given to be what? 2.5. The 2.5 meter per second, is it diameter 300 mm or diameter 200 mm? Okay, diameter 300 mm. Meaning V2 is equals to 2.5 meter per second. Then V3 unknown, right? V3 unknown. Recall what's the formula for area? Area is equals to pi d square over 4. Let's get the value of area in section 1, in section 2, and section 3. For section 1, I have that area A is equals to pi, all into bracket. What's the diameter? 0.45 square divided by 4. What's the answer? Similarly, for section 2, what's your area? A2 is equals to what? Pi, all into bracket, 0.3 square, all divided by 4. Then lastly, for section 3, A3 is equals to what? Pi, all into bracket, 0.2 all square, divided by 4. What's the answer to this? A1 is what? What's the answer? A1 is equal to 0.159 meters squared. A2 is what?
0.07.
0.07 meter squared. Then A3 is what? 0.031 meter squared. Now we've interpreted our question. This is section 1, this is section 2, this is what? Section 3. Now let's draw the diagram. Drawing the diagram, this is what we have. We have this. Right? Now this is section 1, this is section 2, and this is what? Section 3. This is section 1, this is section 2, this is what? Section 3. This is the junction. Meaning from here, we have inflow Q1, we have Q2, we have Q3. By continuity equation, we have that Q1 is equals to Q2 plus Q3. By continuity equation, we have that Q1, the inlet, is equals to the what? Outlet. The inlet is equals to the what? Outlet. Now, go back to Roman figure 1. For Roman figure 1, what are we asked to calculate?
The quantity of flow in the water.
The quantity of flow in 450 millimeter. Now, identify. Your 450 millimeter is if section 1, section 2, section 3, section 1. So what that means is that calculate the quantity of flow in section 1. Now, using the parameter of section 1, your quantity of flow, meaning Q1, which is equals to Q, is equals to what? You know, your formula is equals to Q is equals to A times V. So what do you have? What's the area? 0.159. What's the velocity? 3. Input this in your calculator. What's the answer? 0.477. What will be the unit? Meter cube per second. Now, the idea is that to know if you are correct at the end of by the time you solve finish, to know if you are correct. By continuity equation, what it means is that the summation of the quantity of flow in Q2, the quantity of flow in section 2 and section 3, by the time you add it, you must get this value. By the time you get this value, meaning continuity equation has been satisfied, it has been met. Do you understand what I'm saying? But that's not what we have to calculate. But you can just show that to know that you are correct. Now, we've answered question 1. Question 2 is what?
The velocity of Q2 and Q3.
The velocity of Q3.
Section 3, I mean.
The velocity of section 3. Now, velocity of section 3. Meaning that applying continuity equation, Roman figure 2 becomes what? Q1, which is equals to Q2 plus Q3. Right? Substitute this formula. Meaning A1, V1 is equals to A2 plus, A2 V2 plus A3 V3. What are we calculating? V3. Make V3 the subject of the formula. It becomes what? A1 V1 minus what? A2 V2 equals to A3 V3. Right? Yes. Divide both side by A3. Divide both side by A3. Therefore, the velocity in section 3 by formula, what do you have? A1 V1 minus A2 V2 divided by what? A3. Now, go back to each section. Go back to what? Each section. Call this equation 1. Go back to each section and substitute the respective parameters inside section 1. V3 is equals to what? What's our A1?
0.159.
0.159 multiplied by 0.159 multiplied by what? 3, right? Open bracket. What's our V1?
0.07.
V1.
3.
3 minus all into bracket. A2 is what?
0.07.
0.07 multiplied by V2 is what? 2.5. All divided by what's A3? 0.031. Now you put this in your calculator. What's V3? 9.742 meter per second. Approximately 9.7 meter per second. Meaning that the unknown here is what? 9.7 meter per second. And we said this, we are actually done with the question, right? But to know if you are correct, check if the value satisfy continuity equation. Now what this means is that in section 2, let's get the quantity of fluid here, meaning the area and the velocity. What's our area? 0.031 multiplied by what's our velocity? 0.031 times 9.7. What's the answer?
0.3.
0.031 times 9.7. What do you have? 0.3. This is equals to what? 0.3 meter cube per second. Now for section 2, let's get the quantity of flow. That's what? 0.07 times 2.5. What's the answer? 0.175 meter cube per second. Therefore, for this data to satisfy continuity equation, Q1 is equals to Q2 plus Q3. And we've gotten Q1 to be what? 0.4777 meter cube per second must be equals to Q2 plus Q3. Now, what's Q2? What's Q2? 0.175. What's Q3? 0.3. Now, sum this up. What do you have? 0.475 meter cube per second. 0.477 meter cube per second. Approximately Q is equal to 0.48 meter cube per second. That's it. Meaning the quantity of flow entering that pipe, entering this pipe, the pipe, this is the pipe. Meaning the quantity of flow, the inlet, and these are the outlets. These are the outlets. This is also the outlet. Meaning the quantity entry is this guy, and the outlet is this guy. You understand what I'm saying?
Yes.
So that's it.